Hello, and welcome to our clinic today. Title of the clinic, What is an Arduino? And maybe more importantly, why should you care? Part 2. And some of you may remember that I did an Arduino clinic back in June, where I talked a lot about not only what is an Arduino, but a lot of the things you can possibly do with an Arduino in model railroading. That clinic is on the Division 8 YouTube channel. Should you want to go back and take another look at it, or maybe you missed it back in June and you would like to check it out. It is on the YouTube channel. What? You didn't know we had a Division 8 YouTube channel? Yes, we do. Thanks to the work from guys like Ron Ellison, Fred Soward, Tom Guthner, we have a nice YouTube channel, got several nice videos on there. If you don't know about it, shame on you. You need to go check it out, and while you're there, subscribe. There's my shameless plug for today. So today, though, we're going to do a kind of a quick review to get everybody kind of up to speed. First off, the obvious question, what the heck is an Arduino? Well, this is an Arduino. This is called a microcontroller. Definition of a microcontroller is a microprocessor, a computer chip, with other peripherals mounted on the same circuit board. This allows a microcontroller, through its inputs, to sense things in the outside world, and then using its outputs, make a small external loads operate, be it LEDs, servos, stepper motor, other things. It's a small unit, got very little power. It'll only put out like 0.3 of an amp total. The grand total of memory in this thing is 64K. Yeah, like a Commodore 64 computer, if you remember that. But it is amazing what people have been able to do with this thing. It was developed 15 years ago in Italy, hence the name. And it is the darling of the robotics people, the experimenters, and now more and more the model train people. It has limited capability, but there is enough room in this thing, enough power to get done an amazing amount of things. So we will talk about a lot of those as we move on today. So that's an Arduino. Now, there's a whole family of these. This is actually the Arduino Uno. Number one, the original, still far and away the most popular size. It's like the HO scale of Arduinos. But there are others. There's a Mega that's larger than this physically, has a little more capability, more inputs, more outputs. Then there's another one a little bit smaller than the Uno called the Mini. And then there is this one, the aptly named Nano. One of the great things about the Arduino family is the same program, as they call it, Sketch, will work in any of the Arduinos, no matter Mega, Uno, Mini, or Nano. The same program will work. So a lot of people will use the Uno to kind of prototype the thing. It's easier to handle, easier to deal with the plug-in inputs and outputs. And then when they get it done, they use something like this and put it on a we'll call a Kerf board, a circuit board, and solder everything together, and it goes. So you'll see more about that here in a little bit. So there's a whole family of these. Most of the time when somebody says Arduino, they're actually talking about the Uno. I'm going to talk a moment here about the term open source. Like I said, this was developed 15 years ago in Italy. The developers actually came up with this as an aid for students learning to program. That's what it was designed to do. Thanks to their magnanimous attitude, they didn't bother to patent it or copyright it or anything else. So the Arduino is an open source piece of equipment, which means that anybody can build them, and several people do. All they have to do is conform to the specifications that Arduino sets out. And so when you go shopping for these things, and we'll talk about that in just a second, you'll see that they're available from lots of different sources. So thanks to those folks for not having us pay royalties every time we buy a piece of this equipment. And so open source, great term. At the June clinic, I showed one slide, and on that slide was 26 possible uses for an Arduino in model railroading. And that was just a good start. There are many more, and I see new ones all the time as I go on the internet and look around. People dreaming up things all the time to do with these Arduinos. So if you can dream up something you think you'd like to do with an Arduino, chances are somebody's probably already done it. There's a sketch already out there for it. Vendors. Where do you get the hardware? Well, most of the stuff that I have, I bought through Amazon. Just because I'm used to shopping on Amazon. They also sell it on eBay. I've been told it's slightly cheaper on eBay, so it's your money. You do the shopping around. The online electronics companies, such as All Electronics and the other ones out there, also sell the Arduinos. So once again, it's your money. Shop around. Make your best deal. Maybe you're looking for a specific piece of equipment, and you have to hunt and find it. But it's all on the internet. I know of no local place that sells Arduinos. Where do you start? If you're starting out cold with Arduinos and you'd like to know more about them, the only place to start, not a place to start, the only place to start is this website right here, www.arduino.cc. It's the official, certified, if you will, Arduino website. On that website, you learn from step A to step B and on. It is amazing. It's very well written. It's in plain English, not geek world. It is a joy to go. In there, they have tutorials that teach you how to deal with these things, how to work with them. They tell you, for instance, when you find a sketch, a program online somewhere, at some other source, how to download that program into your computer, into a library file that they show you how to build on your computer, and then how to get them from that library file and upload them into the Arduino itself. And all that is explained on this Arduino.cc. So that's the only place to start. Easy peasy. This is really, really easy. And if you start here, and like I say, go step A and then step B, you get it, and you get it very quickly. Now, sketches. I mentioned those several times already. Where do you get programs, sketches? Once again, online, obviously. And I have developed several sources here that you see that are my favorites. My go-to thing when I'm looking for a specific sketch to do whatever. This first one up here, if you don't already know about this, you are missing out big. And that's Model Railroad Hobbyist Online Magazine. This is a great, great resource. Very, very well written. It comes out once a month. It's got 100 and something pages each month, and it's free. It covers all facets of model railroading. It's incredible, the information that's there. But we're talking about Arduinos. So you want to check out anything that Jeff Bunza has contributed to Model Railroad Hobbyist. By the way, this has a great search function in it. You can go on their website and look up Jeff Bunza, and it'll show you everything he's contributed to this magazine. He turns out some incredible Arduino work and does a great job of writing about it and explaining what he's doing. He does very basic things to help you get started. And here lately, he's been doing some extremely complicated stuff that is kind of befitting to this guy who is a PhD engineer, Dr. Jeff Bunza. So check out Model Railroad Hobbyist for various reasons. Next thing I look into is a site and a YouTube channel called DIY and Digital Railroad. John that runs this does a great job with coming up with Arduino programs Once again, it's a larger thing than just Arduinos, but there's a lot of Arduino stuff on that YouTube channel. He does a great job explaining it, showing it, demonstrating it. In fact, the first demonstration I have today is one of his sketches that I have uploaded into an Arduino here for us today. The next one, Tom's Trains and Things. Well, Tom that runs this one is we'll call him eccentric. He kind of comes and goes. He's goes kind of off on a tangent occasionally, but the Arduino articles that he has, the videos that he has posted, are quite good. He does do a very nice job with that. He's just a little hard to hang with sometimes, but a good source nonetheless. Next one, Model Railroader Video Plus. These first three I've talked about, they're free. This one is a subscription. This, of course, if you've probably already heard of it, it's the video side of Model Railroad Magazine. It's a great, great site. I really like it. It's about $30 a year. I subscribe. You check it out. You make your own choices, of course. But here again, talking about Arduinos, I mean, they have every kind of model railroad information on there you can think of. But as far as Arduinos, you want to check out two names. Jerry Leone, which a lot of you probably know that name already. He shows up all over the internet, does an outstanding job with everything he touches. You may have met him actually in Cincinnati a couple years ago at the convention. He's got a couple Arduino articles on there that are really good. The other one is Ben Lake. He, for the last 3, 4, maybe longer years with Video Plus, has been their behind the camera technical guy. Does the editing, the producing, that sort of thing. Here lately, he's starting to get on the other side of the camera and starting to do some videos on electronics in model railroading. And he's done a couple of things with the Arduinos that are pretty good too. So you want to check these two names out in Video Plus. And of course, there's always Mr. Google. Mr. Google has all of the information from the entire planet, literally. So if you're searching for something, that's always your go-to deal. In fact, you want to try it out, type in Arduinos in model railroading, and then just kind of stand back because it's going to explode right in front of you. So always a go-to place for searches. Here lately, I've been getting into Pinterest. Some of you know that I'm not much of a social media sort of guy. I don't do a lot of that. Got into the Pinterest thing kind of by accident. And then once the Pinterest people figure out what you're interested in, then they flood you with it. So I get at least once a day, I'll get a whole selection of Arduino stuff and Arduinos in model railroading. Some of it's in Russian, some of it's in Spanish, so you got to work around that a little bit. But nonetheless, a lot of good information there. So these are my sources. These are where I go to when I'm looking for sketches, when I need something to make something go. I start checking here and then wherever else I need to go. So enough of this. Time to get to the meat of today's clinic. 2 demonstrations. The first one we've got on the table right here, grade crossing that has gates and a bell. And the other one, I'm just going to let that sit and we'll talk about that when we get to it. So right here on the table is our grade crossing demonstration. First thing you notice is this was not built by Chris Broughton or Bob Kukler or probably anybody else that's watching right now. Just know that it was a quickie. It's some foam and a hot glue gun. And here is our demonstration model right here. Okay. Right here in front, here is the Uno, the Arduino already programmed. Nice thing about these things, once you program them, they no longer have to be hooked to a computer or anything. The program stays in them until you reprogram it to something else. So, all you have to do is supply power. We'll talk about that in a second. So you see the Uno's got several wires coming out of it, inputs and outputs of the Arduino. Going into this white thing, this is called a breadboard. Got several hundred holes in it, and they interconnect. So it allows you to connect the Arduino through the breadboard to the input sensors or the output external loads. In this case, the input sensors are photoresistors. There's one in the track here and another one right here. Photoresistors are like electric eyes. When the light gets darkened, the resistance changes, and then that sends the Uno a signal that something's happened. Then the program, the sketch, then kicks out the output depending on what the program says. So we have one photoresistor here, like I said, and one here. The nice thing is an HO track, they fit right between the cross ties. And then here we have a pair of NJ International crossing gates. Nice gates, not exactly cheap, but not a big fan. If I have a moment, I'll tell you about that later. But at any rate, they're here. Got gates, got lights. Hold my train here. We'll tip it back. You can maybe see underneath. Back here, you've got a servo for this gate, and then there's a little servo right here for this gate. These are small servos. Remember, the Arduino has very little output power, so you got to be conscious of how much of a drain you're putting on this thing. So the wires you see go not only to the servos, but also for the lights, and also for the sensors. So that's why you have this massive wire, kind of a rat nest looking thing right there. We'll talk about a way to clean that up here later. But there it is. All you have to do now is turn the power on, and it's ready to go. Now I'm using just a 12-volt wall wart transformer here, one of these things that everybody's got them laying around. Another one of the great things about Arduinos is they're not terribly picky about input power. As long as it's between 5 volts and 12 volts DC, put AC in it, you have to buy another Arduino. 5 and 12 volts DC. There's a built-in voltage regulator, so it takes care of it so that the output is either 3.3 or 5 volts, depending on what you need for what you're doing. So you can add power in using that wall wart. You can use a plug-in 9-volt battery thing like this. You can even use a cell phone charger. Everybody's got those around. You just stick the correct USB cable in it. And it has a USB connector here. It has a bayonet connector here. That's what I have my power plugged into. You can even hardwire to it. It's just not very picky. And so we have the power, and I just turn it on. Now it's ready. The system is powered. So our train rolls in. Our first sensors here, our inbound sensor. And then you see that turns on the lights, drops the gates. Now these lights only have, these crossing gates only have lights on one side. So you have to believe me that they're flashing on this one too. So trains rolling by, however long it takes, however many cars you have. And then the last car gets here. It rolls over the outbound sensor, but that doesn't trigger it. It has to roll over it and then uncover it, and then that starts a delay, so that the light between each of the cars hitting that sensor doesn't drive this thing nuts. So there's a delay on the outbound sensor. Lights go off, gates come up. And I promised a bell, didn't I? I said a bell earlier. You didn't hear a bell, did you? Well, here's the bell right here. This is a mini MP3 player. In fact, right here is a micro SD card with the bell file on it. And you have to believe me when I say set on the board and wire it in, it does work. It does go ding, ding, ding while the gates are down. But then I realized I wouldn't be able to talk over it while it was going, so I pulled it back off. So you have to kind of believe me when I say it does work with the bells. Now, obviously, I'm reaching over it, and that's what triggered it. I darkened it for an instant. This is unidirectional, as you see here. Not real good. Most railroads run in both directions. Well, the program, the sketch that's already in here, is set up for bidirectional. Now, in order to have another sensor out here for your eastbound train, we'll call it, would need to have a demo, would need to be another couple feet longer. Not room, don't need it. But we just suffice to say that with another inbound sensor out here and an outbound sensor here, that it would work in this direction also. And the programming locks out the one that doesn't trigger it, if that makes any sense. So it does work. You see that it works, and it does a masterful job. That's the part I don't like. We'll talk about that later. But right now, we're going to switch. And when I come back, we'll see the other demonstration. Well, here we are again. As they used to say, through the magic of videotape, the crossing gate demonstration is gone. Now we have this one here on the table. It looks a lot simpler, but it's the exact opposite. There's more here than what you first see. But before we leave the crossing gate altogether, there's a couple of points that I need to make that I didn't make earlier. One of them, I mentioned the rat nest of wiring that you saw there, and it is between the Uno, the breadboard, and then, of course, the actual connections. You wouldn't want to put that under your layout. A, if they're just plugged together and they would fall apart, and B, it's just a mess and it would be hard to deal with. I mentioned earlier that you have these Nanos, for instance, and then this is called a Kerf board. It's just a little universal circuit board. The Nano is designed to drop right onto the Kerf board, any way you want to put it on there. These boards come in numerous sizes and shapes. But what you would do with that crossing gate, for instance, is after you get it figured out, like we have here, it works well. You would then use the Nano and then actually put the wires right in through the holes in the Kerf board, and then on the backside, you would solder the appropriate pins on the Nano to the appropriate wires, and then you'd have one unit like this with the wires coming out of it to go to the crossing gate, the lights, and to the sensors, and this would go under your layout, and you would then have a whole lot neater, more solid, less troublesome unit that you could put under the layout or even in a building or something if you wanted to. So I wanted to clear that up. This is what you would, something like this is what you would end up with instead of what you saw there. The other thing is price. I didn't mention that. That unit that you saw earlier, I'm not talking about the crossing gates because everybody has the different ones they want. You spend the money you want on those. But underneath the layout, the electronics, the servos, what you saw there costs less than $20 to make it happen. If you bought that system, for instance, the under table, I'll call it, the electronics and servos from NJ International, they have a prepackaged deal. It's $150 just for the electronics and the servos. Other people sell the same idea, maybe not quite that expensive. Nobody sells it for less than $20. So that's another one of the many, many big advantages to this Arduino system is the cost, or almost lack thereof. These things, like I mentioned, this Nano, this is $2 or $3 here each. So these are inexpensive things in a nice way to save yourself some money, get the pride of actually putting it together yourself. Okay, crossing gate's gone. Here we are here. Now, what the heck do we have here? What you see in front of you is a full, complete, operational DCC command station. If you run DCC layout or are interested in DCC, you know about a command station. That's the brains, the heart, the item that makes everything go on a DCC system. What you see right here, and then hooked to the computer, is a equivalent of a Digitrax Zephyr, which is a starter system, or the starter set for the NCE. They each go for $2 to $220 as far as cost. What you see right here, not counting the computer, is less than $40. Big difference. Now, this looks a little funny. Doesn't look like what you saw with the crossing system. what we have here is the Arduino itself. The Uno is on the bottom. And then on top here is a thing called a shield. We need to talk a little bit about shields here for a minute. First off, here's another Uno. This one black, which means it's built by a different company. But like I said earlier, completely the same thing. Here's the Uno. Now, the Uno has limited output power. Like I mentioned earlier, approximately 3/10 of an amp. That'll run, like you saw on the crossing gate, and it was about maxed out. It had 4 LEDs and 2 servos and reading the sensors. So that was about max for that Uno on that system. So obviously to run a train layout, a DCC layout, you're going to need a whole lot more power than that. So the Uno needs some help, and that's where the shield comes in. They make many different kinds of shields. This one has pins on it, whether you can see them on a video or not, on the bottom. It also has pins on top. This particular shield is called an expansion board. And this one is designed so that with one Uno and the proper sketch, you can operate up to 19 servos, either all at one time or individually as needed. So by attaching this, and then one of the beauty things here is it goes right in the ports of the Uno, and there it is. It's connected. Now you would add in external power here to have enough juice to run the servos in this case, leaving the Arduino to not get overmatched with the power. So that's how you make it work, and then you can stack more shields up depending on what you're trying to accomplish in this case. So that's a shield. It's a very versatile, lots of different kinds of them out there, depending on what you want to do. Well, in the case of this DCC Plus, as it's called, system, there's the Arduino Uno, and then this shield. It's called a motor shield. This thing can handle up to 3 amps in and output. So you see here, this is the input. I have here just a plain old wall wart, 12-volt wall wart transformer. This one is a 2 amp, because that's what I had. But this will handle up to 3 amps, which incidentally is the maximum amperage for the 2 starter systems from the Digitrax and NCE. Input power comes in here. The output power goes out these other 2 wires through these very high-tech alligator clips you see here hooked to our piece of test track here. That's how you get a Uno to have enough kick to run a complete train layout. So when I first saw and heard about this, I thought there's no way they can make a whole system work. But with the programming that I downloaded off the internet and then uploaded into the Uno, plus connecting it to the computer here, it's a fully functional system. Now, we use on the computer JMRI. A lot of you are familiar with JMRI. I'm not going to get into how that works or what all you can do with it. That's another clinic, probably 2 or 3 clinics for some other time. Just suffice to say that in this situation, we're using one portion of JMRI called Panel Pro. And within Panel Pro is a throttle. This is a throttle just like you would have on a handheld unit or on the face of the Digitrax Zephyr. On the left side there, you see the taller vertical box there. That's the slider. That's the actual throttle itself. You see the little blue indicator down there by stop? You just slide it up, and then it speeds up your locomotive, slows it down. You see it also has a forward, reverse, idle, and stop. And on the right side of that, it says function panel. You see all 15 function keys. Same function keys you have on your throttle. They're right there, including the light. And in the box on the bottom right, you see the address for the locomotive. That's our locomotive we have on the table, our guinea pig here, engine number 3224. Fully functioning panel, just like on any other system. Up at the top, you see a red X. That's a panic button. Oh my God, stop now. And then right beside it, you see off. Well, that's the track power. And by going here to the computer, we have now turned the power on. You see it turned green. Now, what I need to do is turn the sound on. Automatic. The lights are already on. You see there on the locomotive. You see that square. So here we go. This is, and when I turn the track power on, you see the shield lit up with 4 red LEDs. That means we have power in and power out to the track. Track power is on. Obviously, we now have sound on the engine. This is a lock sound decoder equipped locomotive, so it has to go through the whole startup segment before you can move the engine. But so far, you see, we got power to the track. Now, what we're going to do is change the forward direction. And I'm going to slide the slider up here. And there we go. Just like on a regular throttle, this one has a little bit of momentum in it, so I'm going to hit the reverse now, and it slows to a stop, and then it'll start back in the other direction, just like you would expect. Headlight switches, just like it's supposed to. It works just like everywhere else, and if I don't stop it, I'll be picking it up off the floor. Okay, good. So, yes, it works. Yes, it will handle 3 amps. Which will run a small to medium-sized layout. Like I said, whatever you think a Digitrack Zephyr or a NCE Starter will do, this will do also. The JMRI program, I don't think I mentioned, is a free download. More of this wonderful open source stuff that's out there. JMRI does an incredible amount of different things, and the more you get into it, the more you realize you didn't know what you thought you knew about JMRI. So you want to give that a shot. Now, fully functioning, complete command station. Like I said, this happens to have developed the name DCC Plus Plus. It's a mashup of obviously DCC, but also the computer language for the Uno C++. So they mashed them together, and this is called DCC Plus Plus. There's already a button in the panel pro for DCC Plus Plus. You tell it that's what you have coming at it, so it knows what it's reading. Now, that's one great function there, but this thing does another entirely different thing that may be even more functional for a lot of the folks watching out there. And this can also be used as a programming interface. Here again, just like a Pi3 that Digitrack sells for about $130, or a Sprague, which I'm not quite sure what those are. They're 100 and something, I think, but I could be wrong there. Once again, they're quite a bit more than the $40 or less that this costs. And they do the exact same thing that this does, and that is the interface between the railroad and your JMRI, and what in this case would be Decoder Pro, another program within JMRI. If you haven't used Decoder Pro to program your locomotives, you're missing out because it makes it so simple. It just handles all the CV math and all that stuff. You just tell it what you want it to do, and it'll do it. This is your interface between the two things. If you've used especially Digitracks to program using the Digitrack system, you find out that it's kind of lacking in power to program sound-equipped locomotives. It won't do it. So you got to get an add-on something or other to make that work, or switch to the Pi3 and just have it on your workbench programming track, which is probably the best setup of all. So this would accomplish that. Here again, you get the sketch online. You You find your motor shield, you hook them together. There's 2 wires here. That's it. And then the power in, the power out. And then, and of course, the Arduino is hooked by a USB cable to the computer, to the panel probe. So, still sound here a little bit. That's our clinic for today. We want to thank everyone for watching, for listening in, whatever you're doing. I can't get away from here without thanking my wife, Teresa, our chief producer and videographer for our clinic today. Hopefully you enjoyed it. Hopefully you found it of some value, and we'll be talking more later. Who knows? Maybe there'll be a part 3. We'll see.